Section 2, Use and Deploy. In this video, we're going to be taking a look at how to familiarize yourself with kubectl. Kubectl is the native command line interface to Kubernetes. It has a declarative syntax which makes it easy to use and read. There are two key methods of interacting with Kubernetes, and that's through the objects and operators that are involved with kubectl. There are also some special operators that allow you to do certain things to either make it easier on yourself or to filter out specific items that you're looking for. All of these and more can be found on the Kubernetes documentation site in the link seen below. As stated earlier, declarative syntax is easier to read and understand. It makes each command look more like a statement and less like code. With objects and operators, you have all the means to interact with your cluster. So with objects, that contains all of the object types found within Kubernetes. For example, the simple objects such as your namespaces, pods, services, and volumes, as well as the abstractions that we covered in Section 1. In addition, there are many other object types. All of the object types within Kubernetes can be found on the documentation site. Next, with operators, these are declarative statements that are intended to interact with the objects that you see above. Some very basic operators are get, create, describe, and delete. You also have the option of doing some advanced things such as annotate, label, autoscale, cluster info, which gives you the information about the cluster overall, config, which allows you to switch Kubernetes contexts so you can connect to different clusters, expose, port forward, and run. Again, this is not an exhaustive list, and all of the operators that are available can be found on the documentation site. With respect to special operators, there are three primary special operators that come in very handy. One is custom output, so either -o or ~output that allows you to output the command into a format such as JSON, YAML, JSON path, name, and others. For example, if you wanted to get information about a pod and output that in YAML format and then save that YAML file somewhere, you could then reuse that file to deploy the pod in other clusters. Next is wait for completion, which allows you to wait until the pod or service or deployment that you're working with has completed successfully. This will refresh the screen on a regular interval until the status is updated. Another is sort output. So the ~sort by option uses a JSON path expression to sort the output of the command based on that expression. A common expression that's used is metadata.name, which is just the name of the object that you're looking for. More information about JSON path can be found on GitHub at the project's homepage. Let's dive in and get familiar with kubectl. For starters, let's take a look at what we can do with kubectl. We'll pipe this through less so we can scroll through it a little easier. This will give you all of the commands and different things that you can do through here. Pretty seamless. Now, in order to use this, obviously we have to have an active context to a Kubernetes cluster. And what I'm going to do is start up Minikube, make sure that Minikube is running, and then we can run a couple of simple commands against the cluster. Now that that's started up, let's go ahead and run a couple of quick kubectl commands. So for example, let's run cluster info. That'll give you the local IP address, give you the address of the DNS proxy, and you can get further information as stated here by running kubectl cluster info dump. That'll give you a whole bunch more information. Let's dive a little bit deeper and get pods. So you can see I've got a SQL Server pod running on this one. One thing to keep in mind is that kubectl, unless otherwise specified, will run against the default namespace only. If you want to get other items that are in other namespaces, you need to specify the namespace or give it the option of all namespaces. For example, if we were to do this, we would get all of the running pods across all namespaces. You can see here that not only do we have the default namespace, but we also have the kube system namespace where all of the system level pods are being run. We can also get more information on each of the pods by running describe. Now that's quite a bit of information, but it does give you some insight into what's going on. So it gives you the start time, any labels that were applied, annotations that were applied, what the IP is internally, some state information, some environment variable information. Keep in mind this is not a best practice. This is only for demonstration purposes. And it gives you a quick peek into the events on that specific pod. You can also get any running services. As you can see here, we have 2 running services. And if we wanted to run a describe on those, we'll get a little bit more detail. You can also create resources using kubectl or delete them. To show off a little bit of the special operators, let's go back to get pods all namespaces, and let's throw in a sort by. As you can see there, the sort by worked. Everything is in alphabetical order according to pod name. You can also take a look at the nodes, including the describe function, which gives you specific pods on specific nodes, and will tell you how much of your requests and your limits are being hit. It's good information for troubleshooting and cluster administration as well. Let's take a look at another one of the special operators, which is output. In this example here, we're telling kubectl to return all the pods that have the label app equals MSSQL. If you remember, a little bit ago, we did a describe on the pods in the default namespace, and one of them was an MS SQL Server pod, which had a label on it that was set equal to MS SQL. What I anticipate this doing is returning the YAML associated with that particular pod's deployment. And you can see here that it does in fact give us quite a bit of information. You can see the environment variable set here. You can see the image that it's pulling from. You can see what the name of it is. You can also see that it's deployed as a replica set. Now, if we wanted to save this output, for example, we would simply do this and put it into a SQL pod YAML. And then to take a look at it, we can do a quick command line to open code. And you can see here that we have the output of that in YAML format. Now, if we were to reuse this, we could drop off the rest of this file, leaving only the spec and the metadata available. This will allow us to reuse this for future deployments if we want to. Now, some of these name items, generate name, pod template hash, things like that, those can all be removed, as well as trying to use a file with those in there may result in some errors. However, we do now have at least a baseline for some functionality in that YAML file that we can use in the same cluster or across different clusters.